Here we are with the summative review for 1A, your first test. Okay, we're going to walk through the same problems from in class. If you are in class today, this should just be a refresher. If you are not in class today, this is what we did, and then you will be all caught up. So we have solving by substitution or elimination. We're going to do the odds. If I'm looking at 4x minus y equals 18, and then 6x plus 2y equals 13, does that look like an elimination or a substitution problem? Okay, I'm feeling feeling elimination because I know I can just multiply that top row by 2, and that will give me a minus 2y, which will cancel out the plus 2y. Then I'm going to do a little squiggly through there. I'm not going to black it out, just a little squiggly so I know not to use it. We're going to add down 14x, the y's cancel out, 49. Then we can divide by 14. This is a good problem to do because it doesn't equal a perfect number, 7/2 or 3.5. Okay, so you can get a decimal and it is okay. Next, we're going to substitute that x equals 3.5 back into any of the problems. The bottom line, the middle line that's original there, that's why I don't black it out. What if I want to use that one? Or even your new one up there. I'm going to use the bottom one. 6 times 3.5 plus 2y equals 13. Okay, 6 times 3.5 should be 21. When I subtract the 21 over, (2y equals -8). And we'll get y equals -4 for a final answer of 3.5, comma, -4. You can double check those by plugging them in and making sure they equal out. Okay, number 3, substitution. It's a big hint that it's substitution because it already has y equals or x equals. One of the variables is already solved for, so then I can just straight substitute it in. We'll have 3x plus 2 times, not 2 times y. We're going to substitute that in for y, and we'll have 2 times 2x minus 4. See how we substituted that in for y. Then we'll distribute 4x minus 4 equals -8. 2 times 4 is 8, Mr. Handke. Put our 3x and 4x together for 7x. Add the 8. And divide by 7, and we should get x equals 3. And now we already have a nice equation for y. Y equals 2x minus 4, so 2 times 3 minus 4. And we have 3, 2. Okay, there's substitution and elimination. Reminder that both of those go together to make a 1, or a one thing, one item on the test. That's an A and a B on the test, just like it was on the quiz. Okay, next, your calculator problem, 3 by 3 matrices on the calculator. We got Mo, Darby, and Izzy buying school supplies. Mo buys 7 pencils, 4 erasers, 3 notebooks, and spends $8.25. Darby gets 2 pencils, 2 erasers, 6 notebooks, and spends $9. Izzy gets 6 pencils, 5 erasers, 4 notebooks, and spends $9.25. Okay, so step 1, I know it's a bit extra, but we're going to set up a system of equations. Well, even before that, I like to label these right on the problem. Pencils are going to be X, erasers are going to be Y, notebooks are Z. If you don't like that, you can write them off to the side. X equals pencils, Y equals erasers, Z equals notebooks. I just like to do it right on top of the problem. Okay, now we're going to do a system of equations, even though we're going to use matrices. So we got 7x plus 4y plus 3z, 825, 2x, 2y, 6z is $9 even. Must be a tax-free weekend on school supplies. 6x plus 5y plus 4z, $9.25. Okay, then we're going to turn it into a matrix problem. 7, 4, 3, 2, 2, 6, 6, 5, 4 times x, y, z equals 825, 9, and 925. All right, typing that in. Let's zoom out a little bit so I can see the whole thing. Typing that in. Okay, second matrix. Slide over to edit. And we're going to edit our first one, matrix A, and we want that to be a 3 by 3. Okay, we're going to type them in, and I think this one, nope, we don't have it in there. So 7, enter. 4, enter. 3, enter. 2, enter. 2, enter. 6, enter. 6, enter. 5, enter. 4. Now to do the answer matrix, we're going to do second matrix again. Slide over to edit again, and this time we're going to go down to matrix B, 3 by 1, and we want 8.25, enter, 9.00, which is 9, and 9.25, enter. Now comes the weird step. We have to hit quit. Second, quit to get back to the main screen. If you don't do that, when you go to type in A times B, then it tries to do it and put the answer back in that little that box that you were currently highlighting, and then it doesn't like that. Okay, now we're ready to do the math. We're not going to use edit. We're going to do second matrix, and we're going to stay under names. We want A, and then we want the inverse, which is the same button we've been using to get to matrix, just this time we're not going to push second. We're just going to go regular x inverse, which gives us that -1. That's going to give us the inverse matrix of A times second matrix, slide down to matrix B. So that's how we're getting A inverse times B. 0.5, 0.25, and 1.25. So 50 cents, 25 cents, and $1.25. On our paper, we need to show doing A inverse, and A inverse will cancel out A. And we're left with x, y, z equals 0.5, 0.25, and 1.25. And we should probably write that as a coordinate point with the dollars. So 50 cents, 25 cents and $1.25. There we go. A lot of writing with the matrices. All right, turn the page. We have a system, a 2x2 system of equations that we're going to use matrices by hand for. So step 1, just like with the 3x3s, we're going to turn this into a system or a matrix equation. So we're going to have 2, negative 3, negative 2, 2, times xy equals 4, negative 6. Okay, take a look at that. See where those numbers are coming from. Then we need to come up with the inverse. We need to create it. And you have hints at the top to create it. So our determinant equals the difference of the diagonals. A times D, so 2 times 2, minus B times C, negative 3 times negative 2. A lot of negatives going on over there. It's going to be 4 minus 6, or negative 2. That's our determinant. Your inverse formula is 1 over the determinant. So we'll have 1 over negative 2 times these two flip-flop spots, and you won't be able to tell what's going on because they're both 2's, but they traded spots. And these two changed their signs. So negative 3 is now positive 3, and negative 2 is now positive 2. I'm going to multiply that negative half in there. And I'll have negative 1, negative 3 halves, negative 1, negative 1. That's the inverse. That's our inverse matrix. Still not done. Okay, to solve, just like if this was 3x equals 12, you would like multiply both sides by 1/3 or divide both sides by 3. We're going to do the same thing, same idea. We're going to do the inverse to both sides. We're going to multiply the inverse to the front of both sides. So I have the inverse on the front of the left-hand side. And the inverse goes also in the front of the right-hand side. That's a negative 3 halves. Okay, now we went through how to do all these on when we did the notes, and we showed how this is 1, 0, 0, 1. So we're going to cancel these out. And now I just have x equals that. And I do need to see the multiplication here. Okay, so we're going to go row times column. Row times column. So negative 1 times 4 is negative 4. And then negative 3 halves times negative 6 is going to be a positive 9. So that should be 5 on the top. And then the bottom row times this column will have negative 4 and a positive 6. For positive 2. Or 5, comma 2. Okay, a lot of work there. We turned it into, from equations to matrices. Then we used our hints on top to make the determinant and make the inverse matrix to that one on the left. Then we multiply that inverse matrix to the front of both sides of that equation. That cancels out on the left. We have xy equals. And then we have to show our work for the one on the right. And we get 5, 2. And then the next question is prove those matrices from number 7 are inverses. So now we're actually going to rewrite those and multiply them out and prove they are inverses. And when we multiply them out, what should they equal to if they are inverses? What would prove it? If they multiplied to 1001. We have to show it. You just can't write down equals 1001. So row times column. Top row, left column gives me the top left corner. That's going to be negative 2. And that's negative 1.5 times negative 2. That's going to be a plus 3. So that's actually going to be a 1. Top row, right column will have positive 3 and negative 3 for a 0. Bottom row, left column will have negative 2 and positive 2 for 0. Bottom row, right column will have positive 3, negative 2 for a 1. And we have to show it both ways. Okay? I know it's a lot of little tedious work steps. You can do it. Okay, so we're going to flip these around and do it the other way. And I'm going to push pause, or I'll let you push pause and finish that out. All right, welcome back. Let's see. The bottom one, we should be getting negative 2 plus 3 for a 1. Negative 3 and 3, 2 and negative 2, zeros. And then 3 minus 2 gives us a 1. There you go, 1001. It works. All right, good luck on your test tomorrow, guys. Check Schoology for the answer key to your test review. Let me know if you have any questions. We'll see you next time. Good luck.